Now we are going to implement an example with the help of SVM support vector machine algorithm of supervised machine learning. And for that we are using the breast cancer dataset, and we have imported it from the sklearn dataset. You can check it in the original documentation also. It has two classes. Sample classes are given, that is melangen and benign. These are the two types of cancers which have been detected. You can see here further in the parameters, target names, melangen and benign. And the dimensionality is 30. That means there are in total 30 features, and sample total is 569. That means there are 569 rows. So firstly we have imported those, and from sklearn we have imported the matrix also. From pandas we import pandas as PD and numpy as NP. Next we have loaded the dataset like we used to load for Boston House and Iris dataset also, and other digits etc. From sklearn.dataset import load breast cancer, and that we have stored in the cancer variable. Next we have defined our data, actually defining our data for the feature values, and we have stored it in the data frame and stored it in the variable x. And firstly we have printed the features name which are there, and then we have also added a new column named target, and then we have printed the first 5 set of data sets. So here you can see that these are the all data sets which are there, and lastly we have added a target also. Now here target 0 and 1, that will I'll show you later that what does this 0 and 1 signifies. But firstly we check that what are the feature names which are there. So these are the actually features name: mean radius, mean texture, mean perimeter, area, smoothness, compactness, concavity, etc. And next we are going to print the target names which are there. So the target names 0 and 1 which we saw there actually defines the malignant and benign, the two types of cancer detection which are there. So these are the two classes which are being detected. So that is represented with 0 for malignant and benign is represented with 1. Next what we done, that for the target value equals to 0, that means where the value is 0, we have taken those and stored them in the data frame df0. Like this. So here we can get the top 50 records which are, so here you can see that the top 50 records have been sorted which are there having the target value as 0. Where the target value is 0, those records have been sorted. Similarly we have done for where the target value is 1. Here you can see that target value equals to 1, print those 50 records, and we have stored them in data frame 1. So where the target value is 1, those values are also printed. Here you can see that for 1 values. Next what we have done is we have created a function name class, and using the lambda function what we have done is we have added one more column name class that will actually associate with the target name. That means 0 for malignant and 1 for benign, and then it will print those like this. Here you can see that where there is 0, here it is printing malignant, and similarly for 1 also it will print the benign. And right now I've already printed 5 records, that way it is only showing malignant. Next what we have done, mean radius versus mean texture. Here you can see that there are two columns named mean radius and mean texture. So what we have done is we have plotted between those two data frames which are there, mean radius and mean texture, of the data frames df0 that is storing for 0 only, and df1 that is storing the target value for 1. The scatter plot we are plotting here, and we have given the color green and marker plus, and similarly the color blue with the marker dot. And for that we have imported the matplotlib, and from that pyplot. So here you can see that this is the scatter plot which is there of the mean texture and mean radius of the values which are there 0 and 1, that is malignant and benign. Next we have to divide the data and form the test and train model that we used to do in all. We have divided the data, we have dropped the target and the class, and rest data is stored, and target and class are actually our y. That means after predicting this is going to be predicted. So we have divided the data into x and y data set. And next here is the thing to see, that firstly we have used the train test split which we do from sklearn and which we have done for all the models. But now here we have defined a classifier, and sklearn SVM import SVC. Now what this SVC actually is, here you can see that when you will type sklearn.svc and sklearn library. It is a C vector classification. The vector classification is there, that is having several parameters which you can study from the official documentation. So I'm just showing you that these parameters I have passed over there: C, kernel, degree, gamma. We studied about gamma and regularization when we are discussing about the theory of it. So that only I have done here. I have imported the SVC and stored it in CLA, and then I have trained the model with the XTrain and YTrain dataset. And then what we have done is we have predicted several values. So like here you can see, this is the prediction which has been made of 0 and 1 respectively. Then we have checked for the score and accuracy also and printed a confusion matrix. So we have used a simple score function also, and we have used matrices accuracy also for checking the accuracy, and we always check the accuracy of the tested and the predicted values. And then we have printed a confusion matrix of that also. So here you can see that accuracy is same, and this is the prediction, and the diagonal elements 59 and 120, that means these are the correct prediction, and 1 and 8, these are the wrong prediction. That means 9 are the wrong predictions of the model. Next, the tune parameters which we have studied, that is regularization and gamma. So here we are passing the value C, model fit C. Here you can see that, and C is actually C equals to 1, the default value is 1, and what does it do? It is a regularization parameter. The strength of the regularization is inversely proportional to C, must be strictly positive, and the penalty of the squared I2 is the penalty. So this is the value of the C, which is the parameter we have to pass for tuning the model. So when I do that and check the score, so this is the score which is actually returned, and if I increase the value of C, so it gives us a better score. So that means C equals to 10 is the better score. Similarly, I have done here for gamma also, and by default the gamma value is equals to scale, so I have done that value, and I have checked the score after fitting the model. And why we have trained the model again? Because the value of C has changed, so that's why we have trained the model again in both the cases of regularization and gamma. Next, here what we have done, we have used the kernel. Kernel is used to change a 2D model to 3D plane. So like that we have done here. Model linear, here you can see that it has been changed, and C equals to 1. If you don't give any particular parameter, then it takes the by default parameters. And then also we have checked the score of the kernel model which is generated with the help of kernel function. The score is being returned to us. So this is all about support vector machine and how does it work and what are the several parameters which are needed to be passed, and we have operated it using the breast cancer dataset.